called inverses of functions. Okay, and as I was going through this stuff, I immediately noticed there's something that I'm not really sure that you've had in the past. Okay, they immediately start asking you about domain and range. How many people remember what domain and range is? Sounds familiar. Okay, well then. Don't remember. Okay, well let's talk about domain and range. So domain, sorry I just wrote a D, let's write domain. Does anybody know what the domain values are? Nobody, okay. Domain is just all of the x values. Okay, so the range would be the y values. Okay, so all it is just a list of all of the x values and a list of all of the y values. Okay, so in order for you to make a list, you need to do it mathematically correct. Okay, so they also show you different ways to represent a set of numbers. Okay, so I think within these three different forms, okay, you got the inequality, the set notation, and the interval notation. One of those I do believe looks familiar to you. Which one looks familiar to you? Are any of those? The inequality one. Okay, perfect. So let's imagine for a second that we are going to define our range of numbers between -2 and 5. Okay, and we're going to include -2, but not +5. How would I write that as an inequality?
-2 is less than or equal to x less than 5.
Which is less than 5. Perfect. Okay, so everybody understand that notation right there? Does that make sense? Inequality notation. Check. Okay, so set notation, they may ask you to define your domain or your range in set notation. Okay, so set notation is almost identical to the inequality notation, but they add a little bit more stuff. Okay, so they include this, what is this? You guys know what I'm talking about?
Yeah.
I don't know what it's name called. It's called. It's like a
Squiggly.
Squiggly bracket. Squiggly bracket? That's official. We're calling it the squiggly bracket. Okay, so that's going to say an X, and then there's this like long line, which mathematically means such that. So X such that, and then you would just write the same information as the inequality. Okay, so it just is saying the variable that we're going to talk about is X. And so X is all of this stuff. Okay, so the stuff that's after that bar, that such that piece, is what the value of X is. Okay, so you'd write it like this if we're talking about that same set of numbers. Okay, so this is set notation. You probably should write that down, yeah. Okay, now the one thing that's really valuable about set notation versus the other two is that you can list specific values. Okay, so like if my numbers were 1, 2, and 3, and that was it. Just 1, 2, and 3, I can list those as those separate values. Okay, whereas you can't write an inequality like that. You can't just say X is 1 and X is 2. You can't write it as an inequality. So if I was going to list numbers, I would just say, whoops, I already wrote my X. 1, 2, and 3. Yeah, the squiggly bracket. It looks like lips. Lip base kind of. Mine are not very good. Okay, so that's the one nice thing about the set notation versus the other two. Okay, everybody good with set notation? Simple so far? Okay, so interval notation. Okay, now this one is the one that you will see more often in the future. Okay, they use this notation in pre-calculus and in calculus and beyond. it basically ends up looking like an ordered pair. Okay, so if I'm going to list that area between -2, which is including 2, and 5, which does not include 5, I would list it like this. Okay, so there's this bracket. Okay, so the bracket is saying I include the value of 2, and then the parenthesis, oh, -2. Shoot, thank you. -2. So I include the value of -2, and then I do not include the value of 5. Does that make sense to everybody? Okay, so one important thing is that the first number must be the smaller number, and the second number must be the bigger number. So you always go smaller to big. Okay, so you couldn't say from 5 to -2. That would be wrong. There's not a number that's between 5 and -2. That makes no sense, right? That makes sense so far? Good? Okay, let's just do a quick exam, make sure we got it. Okay, so here's this number line. So this time, you guys remember solid circles versus open?
Yeah.
What's solid? Equal to. The whole is not equal to. Okay, so what would my inequality for this number line be? Perfect. Everybody follow that? That's a whole not equal to. Okay, so what would my set notation be?
That after the squiggly bracket.
Squiggly bracket.
With the
X such that -3 is less than or equal to x, which is less than or equal to 2. Squiggly bracket. Okay. And set notation is probably the one that is seen the least. Okay, what would my interval notation be?
-3.
With a bracket or a parenthesis? Bracket.
Brackets.
Mm-hmm. To 2. Bracket. Does everybody kind of follow that? It's pretty simple, right? Do I need to do one more example, like one where we have like a whole? Finite.
Finite. Oh, wow.
Finite. Okay, so finite versus infinite, that's a good point there. So a finite is like bounded region, so you have 2 endpoints versus an infinite region, such as this one. Okay, so this one is saying that all of the values that are less than 2, so how would you say that as an inequality?
X less than or equal to 2.
There you go. X is less than or equal to 2. Okay, so set notation would be x such that x is less than or equal to 2. Okay, how would the interval notation go? What's the smallest value that x could possibly be?
2 values.
Okay, so negative infinity, and you would say negative because you're going in the negative direction. So negative infinity, and just so you know, you always use a parenthesis next to infinity or negative infinity because you can't include infinity. I can't hand you an infinite amount of money. It's impossible. I wish it was possible. Infinitely. It would never stop, right? And then we go to 2 with a bracket. Good? Okay, so that's pretty easy. Did we go over everything? End behavior is something they included in that section, which you don't need to know right now, and we will talk about later. Oh, quickly, let's find the domain of this parabola. Domain in range. Let's do the domain in range. Okay, so the domain. Okay, so domain are the x values. How far to the left and how far to the right does this parabola go? What? Way far to the left and way far to the right, right? So what are those values. Okay, so this is how you would write it. You can say this one of two ways. You can say that the domain can be all real numbers. So you can literally write out all real numbers if you wanted. Or you could say this. Okay, so that's a mathematical symbol for all reals. It looks like an R with two legs. Okay, I will probably use that again, FYI. So all reals in interval notation would be the same as from negative infinity to positive infinity. Okay, so you could say that one of two ways. Okay, what about my range on this? What's the lowest value that y can be? What's the highest value that y can be?
0.
Okay, good. Say it the other way, though. To 0. You always go smallest to biggest. So we could say from negative infinity to 0. And would I include 0? Does it touch 0?
Yes.
Yes. Okay. We could also write this one in inequality notation. We could say that y could be less than or equal to 0. So that's the other way you could write that. Or I guess you could really write that in set notation too. If you felt like it.
Is the domain always real numbers?
On a parabola?
Yeah.
Yes. In fact, usually the domain of a function is usually all real numbers until we start getting into square roots and fractions, which is eventual. We'll get there. All right, so going back to the whole reason we're doing 5-2 is finding inverses. All right, so how do you find an inverse? So here's the little sentence that I'm going to underline. You guys remember what a relation is, right? So a relation is like if I have an input, you give me an output. Input, output. That's a relation. Okay, so if a relation pair is an input x with an output of y, then the inverse relation is an input of y with an output of x. Oh. What happened? It flipped them around. Exactly right. Okay, so this is how you find an inverse. You simply switch the x and the y's.
Wow.
That's all you do. You switch the x and the y's. Okay, so they start with this function, okay, that has 4 ordered pairs, and they switch the first one. So what's the first box right there? 0. What's the next one? 1. So that's really incredibly easy, right? So check this out. This is kind of interesting. So if I look at my domain of my original functions, what are my domain of my original function? Domain. We'll call this of f, of x. What's the domain? What are the x's? What are they? Let's list them. 0, 1, 4. What's the range values? -2, -3, 2, 1. So if we're looking at the inverse, which by the way, the notation is like an exponential -1. That's the notation, which means inverse. Okay, what is the domain values?
It's a real numbers or that.
-2. Yeah, so did you see that?
Flip them around.
Just flip them. Whoops, -4, 0. Shocker, right? Okay, so if they ask you to list the domain and range, you just flip them from the original function. Okay. Do you guys remember mapping diagrams? Do I need to go over what a mapping diagram works? So like it's just another way to list ordered pairs. So -4 goes to -2, 0 goes to -3, 1 goes to 2, and 4 goes to 2. Yep. Yep. So when you flip it, so what is -3 going to go to? 0. It's like you go backwards. So then what is this other box going to be? 1. That's pretty easy. It's like backwards. Too hard? I know. Okay, so this little example is a good one because it makes you take a look at the graph of what happens to inverses. I'm going to start by labeling these points. Okay, so I'm going to say that this first one is A, B, C, and D. So if I have A, B, C, and D, and connect the dots, I think this might be slightly easier to see. So what are the inverse function points? So what's my inverse of A? -2, -4, so that's my A. My B, my C, D, 1, 4. Okay, check this out. Ready? Okay, so my A is going to go -2, -4 right here. There's A. My B is -3, 0. B prime. My C is 2, 1. And my D is 1, 4. What happened graphically to this? Flipped it over what? Oh. Yeah, like that dotted line that's drawn there. Yeah, you guys see the dotted line that's drawn? Here, let me draw it a little darker. Yeah, this dotted line is y equals x. And so what's happening here is the original function is simply reflected over the y equals x line. Okay, why would that even make sense?
Because you flip both the x and the y.
Yeah, that's like what you do, right? So algebraically, you are just literally switching the x and the y, so that just literally reflects the graph over the y equals x line. Okay. So here's a little test for you. See if you understand this reflection idea. I'll even draw in the dotted line for you. Okay, here's my function. Can you reflect that over the y equals x line?
Yeah.
Okay, who's going to do it for me?
Not me.
Oh, not you? I thought you said you. Who wants to do it?
You're gonna have to pick on the calculator.
I'm going to have to what?
The calculator thing.
I'm going to have to pick on the calculator? What do you mean?
It's gonna be sideways, right?
Yeah.
So the mouse is gonna be like.
Oh, I see. Do a random generator? Here, Dawson, you're drawing it. Come on.
Why me? You've already explained it.
Yeah.
But I don't think I'm right.
Just draw what you were doing in the air.
But I don't think that's right, is it?
I don't know. I didn't.
Just draw it on the tablet.
Yeah.
Just like this. Like that?
Yeah, good. Okay, so did everybody else imagine that to happen like that? Oh, it seemed too easy. So one thing that I want you guys to notice. Shh. Hi. So you see these intercepts that are on the x-axis? What did they become? The y-intercepts of the inverse. Okay, so that can help you draw inverses. If they ask you to do this graphically, that's how you can do it. You just reflect it to the other axis. Good? Score. Okay, let's do this algebraically. All right, so making this slightly more complicated. You guys ready? Okay, now this is a little bit of algebra. This is where it gets better. This is the good stuff, in my opinion, I think. Okay, so how can you find an inverse algebraically? I told you how to find the inverse. What do you do?
Swap x. Swap X and Y.
You just switch the x and the y, right? But I don't have a y.
Yeah.
0.
It's really the same as f of x, right? So all I'm going to do is going to switch those, and I'm going to use a y instead of f of x because that looks nicer. So watch what I do here. X is equal to 3y plus 4. Now all I'm going to do is I'm going to solve for the y. How would you solve for y here? Subtract the 4. So I have x minus 4 is equal to 3y. Then what?
So divide by 3.
Divide by 3. Boom. There it is. The inverse is x minus 4 over 3. Now I want you guys to understand that I would accept this as an answer. But if they asked you to graph it, I'm going to guess that like 90% of the people in here couldn't do it that way. Okay, so does everybody realize that this is the same as if I divide both of the top numbers by 3? Okay, so it's like 1/3 x minus 4/3. And now I have y equals mx plus b form, and I can start by graphing that. Okay, do I need to go over how to graph linear equations?
Yeah.
Yeah? Okay, so...
Why? No. No, you're good.
No?
Please, no.
No?
You can.
Okay, well, then I will say no, but if you need help, ask. Right? I'll expect nice graphs. Alright, last thing. Has anybody done composition before? Composition of functions? Okay. So, composition of functions, this is how this works. So they're going to use this wording on your assignment of g of x.
A lot of letters for math.
F of g of x. Okay, so the idea of this is, I'm almost done, you guys. Give me 5 minutes. Almost done. Not if I'm talking, only if you're talking. I don't lose time. Okay, this notation says this is f of g of x. That means I'm going to take the g and plug it into the function of the f. Okay, so if I take my original function way back up here, which was 3x plus 4, 3x plus 4, and I'm going to say my g of x is going to be the inverse that we found. And I'm going to use my original form, the x minus 4 over 3. X minus 4 over 3. Okay, they're going to ask you to prove that two things are inverses by doing a composition. Okay, so what I'm going to do is I'm going to take the g and plug it into the x value of the f function. Okay, so that means when I go to write the x, I'm going to replace it with this whole blue piece. Okay, so it's going to look like this. F of g of x is 3, watch how I'm going to color code this even, x minus 4 over 3 plus 4. Did everybody see that? So I just plugged it in. Good? Follow? Okay, so now if I simplify this, what can I do first thing? Okay, well, I can even go even quicker because look, I got a 3 being multiplied by a 3 that's getting divided. What happens? They cancel, so I can go, and then I have 4, x minus 4 plus 4.
So 0.
Well, so x. Okay, so right here, this is a proof. If I do a composition of two functions and I get an x, that is a proof that they are inverses of each other. Okay, so they will ask you to prove. Remember you guys doing proofs before?
Yeah, they suck.
This one's not so terrible, in my opinion. Okay, so you are proving that they are in fact inverses.
Because x equals x.
Because y equals x. Y is equal to x.
X equals x. Just x. F g of x.
Mm-hmm. So are we good? That was like less than 5 minutes.
Yeah.
Just saying.